Today we're going to be diving deep into CERN.
CERN.
Yeah, the European Organization for Nuclear Research.
Yeah.
And we've got a whole stack of articles and research here all about CERN. So we're going to be looking into the groundbreaking discoveries and the mind-boggling machines and the global community that makes CERN so fascinating.
I think what's so fascinating about CERN is that it's not just a research facility.
Right.
It's really a testament to human collaboration.
Yeah.
You have thousands of scientists
From all over the world.
Yeah, from over 70 countries, all working together to push the boundaries of knowledge.
It's amazing to think about, but let's start with the basics.
Okay.
What exactly is CERN hoping to achieve?
Hmm.
What are they trying to find out when they smash these particles together at the speed of light?
Well, they're trying to understand the fundamental building blocks of the universe.
Oh.
They want to know what everything is made of and how those basic components interact with each other. And to do that, they use some of the most complex and sophisticated scientific instruments ever created. Like massive particle accelerators and incredibly sensitive detectors.
So they're kind of like cosmic detectives.
Yeah.
Searching for clues about the universe's origins and the laws that govern it.
That's a great analogy.
I like that one.
And one of their most powerful tools in this investigation is the Large Hadron Collider, or LHC.
Yeah, the LHC.
Which is the world's largest and highest energy particle collider.
Yeah, and it's a 27-kilometer ring.
It is.
Buried underground.
Underground.
Beneath the French-Swiss border.
That's right.
27 kilometers. That's like running a marathon underground.
Yeah.
I've seen pictures, but I still can't grasp the sheer size of this thing.
It truly is an engineering marvel.
Yeah.
The LHC uses thousands of powerful magnets to guide beams of particles around the ring,
Right.
accelerating them to almost the speed of light before smashing them head-on.
Okay.
These collisions recreate conditions that existed fractions of a second after the Big Bang, giving us a glimpse into the very early universe.
Okay, so they smash these particles together.
Right.
But what are they actually looking for in the debris of these collisions?
They're searching for new particles,
Okay.
new forces, new anything
Very
that can
good.
help us understand the universe better.
Right.
And they've already made some groundbreaking discoveries like the Higgs boson in 2012.
Higgs boson.
Yeah.
That was a big one.
It was a big one.
Yeah.
This particle was a missing piece in the standard model of particle physics.
Oh, the standard model.
Yeah.
Okay, hold on.
Which is the theory that describes the fundamental forces and particles that make up everything we see.
Okay, so can we maybe talk about the standard model a little bit more? I feel like I hear about it all the time,
Yeah.
but I'm not totally sure I understand what it is.
So the standard model is like a blueprint for the universe at the most basic level.
Okay.
It describes the fundamental particles like quarks and leptons.
Quarks.
Yeah. And the forces that govern their interactions, like the electromagnetic force,
Right.
the weak force, and the strong force.
Right.
So the Higgs boson was the final piece of this puzzle.
Okay.
It confirmed a key part of the standard model.
So that must have been a huge moment for the scientific community.
Absolutely. It was a major milestone.
Yeah.
And it earned Peter Higgs and Francois Englert the Nobel Prize in Physics in 2013.
Wow. Yeah, I remember that.
But even with the Higgs boson in place, the standard model doesn't explain everything.
Oh, man.
There are still mysteries. It can't account for like the existence of dark matter
Dark matter.
and dark energy,
Right.
which make up the vast majority of the universe.
So in a way, discovering the Higgs boson was both an ending and a beginning.
Yeah.
It completed the standard model, but it also opened up all these new avenues for exploration.
Exactly.
And CERN is at the forefront of that,
Right.
using the LHC to search for answers to these mysteries.
They're investigating phenomena like supersymmetry.
Supersymmetry.
Yeah, which proposes the existence of partner particles for each particle in the standard model.
Oh, wow.
They're also searching for evidence of extra dimensions,
Extra dimensions.
which could revolutionize our understanding of space and time.
It's also fascinating.
You
But I have to admit, it's a lot to wrap my head around.
can imagine.
So let's back up a little bit.
Okay.
Before the LHC,
Mm-hmm.
how did CERN accelerate particles? I mean, it's not like they just built the most powerful particle collider overnight.
You're absolutely right.
Yeah.
The LHC is the culmination of decades of research and development.
Right.
CERN has a vast network of accelerators,
Yeah.
each one building upon the work of the previous one.
So it's kind of like a chain reaction.
Ah.
Each machine boosting the energy of the particles before passing them on to the next.
Precisely. It all starts with linear accelerators,
Okay.
like LINAC 4,
LINAC 4?
which provide the initial boost to the particles.
Okay.
Then they move on to larger circular accelerators, like the proton synchrotron booster and the superproton synchrotron,
Right.
gaining energy with each step.
Wow.
It's a carefully choreographed dance of particles,
Wait.
each machine playing a crucial role in getting them ready for the grand finale in the LHC.
It sounds incredibly complex, like a giant intricate puzzle where each piece is essential.
It is.
Yeah.
And it takes an incredible amount of precision and expertise to operate these machines.
I bet.
Remember, we're talking about beams of particles traveling at nearly the speed of light?
Right.
Even the slightest misalignment could have disastrous consequences.
Speaking of disasters,
Oh, yeah.
I've heard some pretty wild conspiracy theories about the LHC,
Oh, like what?
like that it could create a black hole and swallow the Earth.
The black hole theory,
Yeah.
while it makes for a dramatic headline,
Yeah.
there's absolutely no scientific basis for it.
Okay.
The energies produced at the LHC are incredibly high, but they're still orders of magnitude lower than what would be required to create a black hole that could threaten Earth.
That's reassuring to hear.
Yeah.
But it is interesting how CERN's work can capture the public's imagination,
Yes.
even sparking some outlandish ideas.
Yeah. It's a testament to the power of science to inspire awe and wonder.
Right.
And while some of the speculation might be a bit far-fetched,
Yeah.
it reflects a genuine public interest in the mysteries of the universe that CERN is trying to unravel.
So we've talked about the LHC, the
Mhm.
standard model,
Yeah.
even black hole conspiracy theories.
Uh-huh.
But let's not forget about the experiments themselves.
Yeah.
There are 8 different experiments housed along the LHC's path, right?
That's right.
Each one designed to study a different aspect of particle physics.
Think of it like a detective agency
Okay.
with specialized teams,
Yeah.
each one focusing on a different type of clue.
Can you give us a few examples? What kind of clues are these experiments looking for?
Well, you have ATLS and CMS, which are general purpose detectors.
Okay.
They're like the all-around detectives looking for any signs of new particles or phenomena that might deviate from the standard model.
Okay.
Then you have specialized experiments like LHCb,
LHCb,
which focuses on particles containing beauty quarks,
beauty quarks.
and ALICE,
Okay.
which studies the Quark-Gluon plasma,
Quark-Gluon plasma.
a state of matter that existed in the very early universe.
Okay, now that sounds intriguing.
It is.
Can you elaborate on that a bit?
So imagine a state of matter where quarks and gluons,
Right.
the particles that make up protons and neutrons,
Right.
are no longer confined within those particles.
Okay.
Instead, they're free to roam around in a sort of soup of fundamental particles.
So it's like taking apart the building blocks of matter
Yes.
and seeing what happens when you let the pieces fly free.
Exactly.
Yeah.
And by studying this quark-gluon plasma, we can gain valuable insights into the conditions that existed just moments after the Big Bang.
It's amazing how CERN is able to recreate these extreme conditions,
It is.
giving us a window into the universe's earliest moments.
Yeah.
But I'm curious, how do they handle the massive amount of data generated by these experiments? I imagine it's not just a matter of jotting down a few numbers in a lab notebook.
You're absolutely right.
Yeah.
The LHC generates an incredible amount of data, about 1 petabyte per second.
1 petabyte per second.
To handle this data deluge, CERN created the worldwide LHC computing grid,
Okay.
which is a global network of computers
Wow.
that processes, analyzes, and distributes this information to researchers around the world.
Wow, a global network of computers just to handle data from a single experiment.
It is.
That speaks volumes about the scale and complexity of CERN's research.
It's a testament to the power of collaboration and the ingenuity of the scientists and engineers who work at CERN.
So we've explored the LHC,
Mm-hmm.
its experiments,
Mm-hmm.
even the global network of computers needed to process the data.
Right.
But CERN's impact extends far beyond particle physics.
It does.
It's also a pioneer in open science,
Yes.
making its research and data freely available to the world. CERN's commitment to open science is truly commendable.
It is.
They believe that scientific knowledge should be accessible to everyone, not just a select few.
That's right.
That's a refreshing approach. In a world where scientific research is often locked behind paywalls and subscription fees.
Yeah,
Can you tell us more about CERN's open science initiatives?
sure.
What specific steps are they taking to make their research accessible?
Well, one of the key initiatives is their open access policy,
Okay.
which ensures that all CERN publications are freely available online.
Okay.
They also have the CERN Open Data Portal,
Right.
where they make vast amounts of research data publicly accessible.
Wow.
And they've developed platforms like Zenodo,
It's a no-do.
which allows researchers from any discipline to share their data and publications openly.
So CERN is not just pushing the boundaries of particle physics.
Right.
They're also leading the way in open science,
Yeah.
democratizing access to scientific knowledge.
Exactly. And this open approach fosters collaboration and accelerates scientific discovery, benefiting researchers and society as a whole.
A powerful example of how science can transcend borders and bring people together in pursuit of knowledge.
Speaking of transcending borders,
Huh?
CERN itself is a testament to international collaboration.
Yeah.
It has 24 member states,
Right.
primarily European nations,
Right.
but with Israel as a unique exception, being geographically outside of Europe.
Yeah, it's a truly global effort with countries from all over the world coming together to unlock the secrets of the universe.
It is.
And they're not just focused on the present, they're also looking ahead to the future of particle physics.
Indeed, even as the LHC continues to produce groundbreaking results,
Right.
CERN is already planning for its successor.
Oh, really?
The Future Circular Collider, or FCC?
The Future Circular Collider. That sounds incredibly ambitious.
Yeah.
Tell me more about this next generation collider.
All right, so imagine this. A colossal ring, almost 100 kilometers in circumference,
Wow.
dwarfing even the mighty LHC.
Wow.
That's the vision for the FCC.
Yeah.
A particle collider with the potential to reach energy levels far beyond anything achievable today.
100-kilometer collider.
Yeah.
That's just mind-boggling. What kind of scientific breakthroughs could such a machine enable?
Whoa.
What mysteries could it help us solve?
The FCC would open up entirely new realms of physics,
Okay.
allowing us to delve deeper into the nature of dark matter,
Right.
the Higgs boson, and potentially uncover new particles and forces that we haven't even imagined yet.
Wow.
It would be a giant leap forward in our understanding of the universe.
It sounds like the FCC could revolutionize particle physics, just as the LHC did before it.
Exactly. And while it's still a long way off with research and development currently underway, the potential rewards are immense.
Yeah.
It's a testament to CERN's commitment to pushing the boundaries of scientific exploration.
Well, this has been a whirlwind tour of CERN.
It has.
From the mind-boggling scale of the LHC to the far-reaching implications of their open science initiatives. But I feel like we've only scratched the surface of what this incredible organization is all about.
You're absolutely right. There's so much more to explore, from CERN's role in inspiring the next generation of scientists to the lab's surprising influence on popular culture.
I'm already eager to dive deeper into those aspects. Stay tuned, everyone, as we continue our deep dives into the amazing world of CERN.
Welcome back to the Deep Dive.
So before the break, we were talking about CERN's ambitious plans for the future with the FCC.
Right, the Future Circular Collider.
Yeah.
Yeah.
But I wanted to shift gears for a moment
Okay.
and talk about another facet of CERN that I find really remarkable,
Okay.
which is its impact on popular culture.
Yeah.
It seems like CERN has really captured the imagination of filmmakers and writers and even musicians.
It has.
It's not every day that you see a scientific organization achieve that kind of cultural status.
It's true. CERN's work, particularly with the LHC,
Right.
it has this aura of mystery and excitement that's hard to resist.
Yeah, that's true.
And it's not just about the science itself, it's about the big questions that CERN is tackling. The fundamental mysteries of the universe.
Yeah, it's about exploring the unknown,
Right.
pushing the boundaries of human knowledge.
It is.
It's no wonder that creative minds are drawn to that kind of narrative.
Exactly. And they've found some really unique ways to incorporate CERN into their work.
Yeah.
You know, remember that band we mentioned earlier?
Yeah.
Les Horribles Sonnets?
Les Horribles Sonnets?
Yeah. They were formed by women from CERN
Oh, yeah.
back in the early days of the web.
Weren't they one of the first bands to have a website?
They were.
Wow.
It's a fun little connection between CERN, the birthplace of the web,
Yeah.
and the world of music.
I love that.
And there are other examples, too, like Catherine McAlpine's Large Hadron Rap.
Oh, yeah, the Large Hadron Rap.
Yeah.
Yeah.
It's a catchy and informative rap video about the LHC that went viral a few years ago.
It's a great example of how science communication can be fun and engaging.
It is.
And it's not just music. CERN has also made appearances in documentaries and fictional works.
Oh, absolutely.
Like
There's Particle Fever,
Particle Fever.
a documentary that follows the scientists at CERN during the search for the Higgs boson.
Oh, yeah.
It gives viewers a real sense of the excitement and the challenges of working at the cutting edge of science.
Yeah, I remember watching that documentary.
Yeah,
It was really inspiring to see the passion and dedication of those scientists.
absolutely.
And then you have CERN popping up in fictional works like Dan Brown's Angels and Demons.
Oh, yes. Angels and Demons.
I love that
A
book.
bit of a thriller.
Yeah.
With CERN's research playing a central role in the plot.
Yeah.
Of course, it takes some liberties with the science.
Right.
But it definitely helped raise public awareness of CERN and particle physics.
Yeah, and we can't forget about CERN's appearances in anime and sci-fi.
Right.
It's amazing how the scientific organization has found its way into such diverse forms of media.
It's a testament to the power of CERN's narrative to capture the imagination.
Yeah.
It speaks to our fascination with the universe,
Right.
the unknown, and the possibilities of scientific discovery.
But it's not all positive, is it?
Whoa.
I've also heard that CERN has been the subject of some pretty wild conspiracy theories.
That's true. There's a darker side to CERN's fame.
Yeah.
Some people see it as a source of potential danger,
Right?
even a threat to humanity.
Yeah.
You mentioned the black hole theory earlier, and there are others out there, ranging from the creation of strangelets, portals to other dimensions.
Yeah, it's interesting how these conspiracy theories often reflect a fear of the unknown,
Right.
a sense of unease with the idea of scientists probing the fundamental nature of reality.
I think you're right. It's a natural human reaction
Yeah.
to be cautious, even fearful when confronted with things we don't fully understand.
Right.
But it's important to remember that CERN's research is conducted with the utmost care
Right.
and with a deep respect for safety and ethical considerations.
Speaking of ethics,
Yeah.
are there specific ethical guidelines that govern CERN's research? I mean, they are dealing with some pretty powerful forces
Yes.
and exploring some pretty fundamental questions about the nature of reality.
Right.
It seems like there's a lot of potential for things to go wrong,
There is.
even unintentionally.
Yeah.
So how do they make sure that doesn't happen?
Well, CERN takes ethical considerations very seriously.
Okay.
They have a dedicated ethics committee
Okay.
that reviews research proposals
Right.
and ensures that all experiments are conducted responsibly
Okay.
and with full transparency.
That's reassuring to hear.
I know.
Can you give us some examples of the ethical issues they might consider? What kind of questions do they grapple with?
Well, one of the primary concerns is the potential impact of CERN's research on the environment.
Right, because they are operating these massive machines
Right.
and conducting experiments that generate high levels of energy.
Exactly. So the ethics committee carefully assesses the environmental impact of each proposed experiment
Okay,
to ensure that it meets strict safety standards.
that makes sense. They wouldn't want to accidentally create a mini black hole in the Swiss countryside.
Exactly. Another area of ethical consideration is the potential for dual-use technologies.
Dual-use technologies.
Yeah, some of the technologies developed at CERN could have applications in other fields,
Okay,
including military applications.
right. So the ethics committee has to weigh the potential benefits of scientific advancement
Right.
against the risks of those technologies being used for harmful purposes.
Precisely. They have to consider the broader societal implications of their research
Yeah.
and ensure that it's used for the betterment of humanity, not for harm.
It's fascinating how ethical considerations are so deeply intertwined with scientific progress,
It is.
especially at a place like CERN where they're pushing the boundaries of what's possible.
Yeah, it's a constant dialogue,
Right.
a balancing act between the pursuit of knowledge
Right.
and the responsibility to use that knowledge wisely.
So we've explored the cultural impact of CERN
Yeah.
from its appearances in pop culture to the ethical considerations that guide its research.
Right.
But let's not forget about the human element at the heart of this scientific endeavor.
That's right. CERN is not just about machines and data, it's about the people.
Right.
The scientists, engineers, technicians, and countless others who work together to make these discoveries possible.
It's a global community united by a shared passion for science and a desire to understand the universe.
Absolutely.
Can you tell us more about what it's like to work at CERN? What's the atmosphere like?
It's an incredibly vibrant and stimulating environment.
Okay.
Imagine walking down a hallway and bumping into a Nobel laureate,
Wow.
or having lunch with someone who's working on a groundbreaking experiment.
That's amazing.
There's a constant exchange of ideas,
Right.
a sense of excitement and intellectual curiosity that's palpable.
That sounds like a dream come true for anyone who loves science.
It is, and the diversity of the community is truly remarkable.
Yeah.
You have people from all over the world, from different backgrounds and cultures, all working together towards a common goal.
It's a testament to the power of science to transcend borders and bring people together.
Absolutely.
But I imagine it's not all fun and games.
Wow.
There must be intense pressure to achieve results,
There is.
especially with so many brilliant minds working together.
Of course, there's pressure, deadlines, and the inevitable setbacks that come with scientific research.
Right.
But there's also a strong sense of camaraderie,
Yeah.
a spirit of collaboration that helps everyone overcome those challenges.
It sounds like a really unique and rewarding experience.
It is.
And it's not just about the research itself. It's about the people,
Right.
the friendships,
Right.
the shared moments of discovery.
Exactly. It's a community that fosters both scientific and personal growth, a place where you can learn from some of the brightest minds in the world and form lifelong connections with people who share your passion.
That's amazing.
It is.
It's really inspiring to hear about this side of CERN,
Yeah,
the human side
the human side.
of this incredible scientific endeavor.
Right.
But let's not forget that CERN's impact extends far beyond its own walls.
It does.
Its research has implications for fields beyond particle physics, right?
Absolutely. We've already talked about CERN's pioneering work in open science
Right.
and its role in developing grid computing,
Yeah.
which has applications in areas like healthcare climate modeling and even financial analysis.
Can you give us some specific examples of how CERN's technologies are being used in other fields?
Yeah.
How are they making a difference in the real world?
Well, one of the most well-known examples is the development of the World Wide Web at CERN.
The World Wide Web.
Tim Berners-Lee, a British scientist at CERN,
Yeah.
created the web in 1989 as a way to facilitate information sharing among researchers.
It's amazing to think that the internet, which has become such an integral part of our lives,
It has.
originated at CERN.
I know, it's a testament to the unexpected ways that fundamental research can lead to transformative technologies.
That's incredible.
And CERN's contributions go beyond the web. They've also played a key role in developing medical imaging techniques, such as PET scans,
Oh, wow.
which are now widely used in healthcare to diagnose and monitor a variety of diseases.
So research that was initially focused on understanding the building blocks of the universe
Right.
is now helping to save lives.
It is.
That's incredible.
That's a powerful reminder of the potential of scientific exploration to benefit society in unexpected ways.
And CERN's commitment to open science ensures that these technologies are accessible to researchers and innovators around the world,
It does.
maximizing their potential impact.
Exactly.
This brings us to another important question. How is CERN funded? I imagine it takes a significant amount of resources to operate such a massive and complex research facility.
You're absolutely right. CERN's annual budget is over 1 billion Swiss francs.
Wow, 1 billion Swiss francs.
And it comes primarily from contributions from its 24 member states.
So it's a truly collaborative effort,
It is.
with multiple countries pooling their resources
Right.
to support this global scientific endeavor.
Exactly. And the member states recognize the value of investing in fundamental research,
All right.
understanding that the knowledge gained at CERN has the potential to lead to scientific breakthroughs and technological advancements that benefit society as a whole.
It's a testament to the power of international cooperation and a shared belief in the importance of scientific discovery.
And it's not just about financial contributions.
Right.
The member states also provide scientific and technical expertise, sending some of their brightest minds to work at CERN.
It's like a global brain trust with the best and brightest from around the world coming together to push the boundaries of human knowledge.
That's a great way to put it.
Yeah.
And this collaborative spirit extends beyond the member states.
Okay.
CERN also has partnerships with universities and research institutions worldwide, fostering a truly global network of scientific collaboration.
Well, this deep dive into CERN has been an incredible journey so far.
It has.
We've explored its history, its groundbreaking discoveries, its cultural impact, the ethical considerations that guide its research, and the global community that makes it all possible.
It's been quite a journey.
But before we wrap things up, I'm curious to know, what are some of the challenges that CERN faces? What obstacles stand in the way of their quest to unravel the mysteries of the universe?
That's a great question. Even with all its resources and expertise, CERN faces its share of challenges.
Okay.
One of the most significant is the sheer complexity of the research itself.
Right.
They're dealing with phenomena that are at the very limits of our understanding,
Yeah.
pushing the boundaries of what's technologically possible.
It's like trying to solve a puzzle
Yeah,
where the pieces are constantly changing,
right.
and you don't even know what the final picture is supposed to look like.
Exactly. And then there are the technological challenges.
Right.
Building and operating machines like the LHC requires pushing the limits of engineering and material science.
Yeah, we're talking about maintaining beams of particles traveling at nearly the speed of light,
Right.
colliding them with incredible precision,
Yes,
and then trying to make sense of the resulting debris.
it's a lot.
Yeah, it sounds mind-bogglingly difficult.
It is, and it takes a team of incredibly talented and dedicated scientists, engineers, and technicians to make it all work.
Yeah, I have so much respect for the people who work at CERN.
I do too.
It takes a special kind of passion and dedication to tackle those challenges head on.
And they're constantly pushing the boundaries, innovating and developing new technologies to overcome these obstacles.
It's inspiring to see that kind of determination and ingenuity at work.
Another challenge CERN faces is securing funding for its ambitious projects.
Right.
As we discussed earlier, CERN relies on contributions from its member states,
Yeah.
and these contributions are not always guaranteed.
So there's always a risk that funding could be cut,
Right.
jeopardizing future research.
That's always a concern, but CERN has a strong track record of success. And its member states recognize the value of investing in fundamental research.
Yeah, let's hope that continues.
Yes.
The world needs places like CERN, where the pursuit of knowledge knows no bounds.
Absolutely. CERN is a beacon of scientific exploration, a symbol of human ingenuity and collaboration.
Well, we've covered a lot of ground in this deep dive into CERN.
We have.
From the subatomic realm of particles to the grand scale of the universe, from the cultural impact of CERN to the ethical considerations that guide its research, it's been an incredible journey.
It has, and we've only scratched the surface.
I know there's still so much more to explore, so much more to discover.
There is.
Stay tuned, everyone, as we continue our deep dive into the amazing world of CERN. Welcome back to the Deep Dive. We've spent this episode exploring the vast and intricate world of CERN, from its groundbreaking discoveries to its complex machines, its global community, and the profound questions it seeks to answer.
It's been quite a journey.
It really has. We've delved into the heart of matter, explored the origins of the universe, and even touched on CERN's influence on popular culture.
We've covered a lot of ground.
We have. We've talked about the challenges CERN faces, the sheer complexity of the research, the constant need for technological innovation, and the importance of securing funding for these ambitious endeavors.
It's not easy work.
It's not. But I think it's important to step back for a moment and consider the broader significance of CERN.
Okay.
Beyond scientific discoveries, beyond the technological advancements, CERN represents something truly profound.
What's that?
It's a testament to the power of human curiosity,
It is.
the relentless pursuit of knowledge,
Yeah.
and the extraordinary things that we can achieve when we work together, transcending borders and differences in the name of scientific exploration.
That's a beautiful way to put it. CERN is a beacon of hope,
Yeah.
a symbol of human ingenuity, and our capacity to collaborate on a global scale to solve some of the universe's most challenging mysteries.
And it's not just about solving mysteries, it's about expanding our understanding of the universe and our place within it. It's about pushing the boundaries of human knowledge and inspiring future generations to continue this grand adventure of discovery.
That's what it's all about.
CERN's impact goes far beyond the scientific community. It inspires young people to pursue careers in STEM fields.
It does.
It fosters international cooperation And it reminds us that we're all part of something much larger than ourselves.
We are.
It sparks our imaginations, it fuels our curiosity, and it encourages us to ask the big questions about our existence.
The big questions like,
Why are we here?
why are we here?
What is the universe made of?
Yeah.
How did it all begin?
These are the questions that have captivated humanity for centuries.
Right?
And CERN is giving us the tools to explore them in ways that were once unimaginable.
That's right. And it's not just about finding answers.
Yeah.
It's also about the journey itself.
Yeah.
The process of exploration, the joy of discovery,
Right.
and the humility that comes with realizing how much we still don't know.
Exactly.
And I think that's one of the most important takeaways from our deep dive into CERN.
What is it?
The recognition that we're still at the beginning of this journey of cosmic exploration. There's so much more to learn.
There is.
So much more to discover.
So much more.
And CERN is leading the way, pushing the boundaries of knowledge, developing new technologies, and fostering international collaboration. It's a shining example of what humanity can achieve when we work together towards a common goal.
It is.
Well, as we wrap up our exploration of CERN, I want to leave our listener with a thought to ponder.
Okay.
We've marveled at the discoveries, the machines, the people, and the global collaboration that makes CERN such an extraordinary place.
Yeah.
But perhaps the most important lesson we can take away is the importance of nurturing our own sense of wonder and curiosity.
Absolutely.
It's about embracing the unknown, asking questions,
Right.
seeking knowledge for the sheer joy of discovery.
Yeah.
It's about looking up at the stars and realizing that we're part of something vast and mysterious,
We are.
something that's still waiting to be explored.
That's a beautiful sentiment to end on.
So to our listener, we encourage you to keep that spirit of curiosity alive. Explore the world around you, ask questions, seek knowledge, and never stop wondering about the mysteries of the universe. Who knows, maybe one day you'll be part of the next groundbreaking discovery at CERN.
Thank you for joining us on this deep dive into the incredible world of CERN.
Until next time, keep exploring.